Okay, so I'm sure all of your eyes are on what are these three lights, right? Okay, so let me start my talk with a demo. Okay. Okay, so the screen on the top left, the window is the screencast of whatever's on my iPad app, and on the bottom right, I've set up a webcam so that this is for the benefit of those at the back who cannot see these three lights. Okay, so now let me start my demo. Okay. Okay, so notice the position of the cross. Okay, so now let me go over to the red. You can see the cross is, I think, somewhere near the red, right? Okay, now I go to the blue. Okay, I'm somewhere in the middle, you can see. The cable is not long enough, but you get the point. Okay, so now this is the second part of my demo, which is to directly control the light colors. So now let me control the one on the left. You can see. So let me set it to cyan, and I'll increase the number of LEDs shown like this, and increase the brightness to max. Then for the middle one, somewhere here, maybe put it lesser. Then, and the one on the right, maybe a bit yellow. Okay, get the point? Okay, so now I'll pass my iPad to you, the audience, so y'all can play with it. Okay, so let's see how this is being done. Okay, so on the hardware side, I have actually 3 Raspberry Pis here. So the Raspberry Pi is equipped with the onboard Wi-Fi and Bluetooth chip, and is running on the Raspbian operating system. And on top of my Raspberry Pi inside, I have actually something called the Unicorn head. So Unicorn head is something like an RGB LED on an 8x8 grid. And other tools, I have my iPad mini. And supporting gear-wise, I have a router here and 3 tripods. And for each of the tripods, they are equipped with their individual battery packs. So that's why you do not see any cables running to any of them. Okay, so this is the layout. Okay, I've arranged the 3 tripods in the format of an equilateral triangle, about 2 meters apart from each other. And this is the overview of the system. So each of these Raspberry Pis, they're actually broadcasting on Bluetooth. And these advertisement packets, the Bluetooth advertisement packets, are captured by my iPad app. Okay? Then the iPad app will then relay the instructions of what LEDs to turn on back to these Raspberry Pis via Wi-Fi. Okay, so this is how the workflow is done. So on my Raspberry Pi, actually there are 2 processors running. I have a Swift app and a Python app. I'll come to why I need a Python app later. So the Swift app is responsible for broadcasting over the Bluetooth. And these packets are captured on my iPad app. I have a Swift app there that can receive the signal strength of these packets. And then it calculates out how much LEDs are required to be shown. Then it will transfer back via UDP to the Swift app again. And transfers this data via a Unix domain socket to the Python app. So a Unix domain socket is something like a form of inter-process communication. So why did I have a Python app? It's because the manufacturer library of this 8x8 grid is written in Python, and I didn't feel I want to rewrite the whole thing in Swift. Okay, so this Unicorn library then controls the grid, you see. Okay, so how do I actually get the distance and signal strength? So let me go to some code. Okay, so on my iPad app, I have to use call Bluetooth, implement a CB Central Manager delegate. Then I need to actually scan for peripherals. So scanning is basically to look for devices. And when I scan, this particular option is actually important, which is scan option all allow duplicates key must be set to true, because default this is actually false. So if it is true, it means that iOS will keep on passing the advertisement packet to my app. If this is false, iOS will only send you for the first time. As for how do I receive the advertisement packets in RSSI, it's actually this delegate function here. Okay, did discover peripheral, and the iOS will actually tell my app the RSSI of the advertisement packet here, and from this I can do something about it. Okay, so what can I do with the RSSI? So actually it's governed by this formula. So there's a relationship between RSSI and distance. So RSSI equals to -10 times some propagation constant times some log distance plus some decibel milliwatt at 1 meter. So this is what it means. So propagation constant is how much the signal will degrade over a certain distance. And this dBm at 1 meter is the reference transmit power, which is -60 for the Raspberry Pi. So we can just rearrange this formula then to make the distance the subject, and we can calculate it out. So just substitute all the values in. Substitute the RSSI here, I get the distance. However, this only works in theory. So in practice, RSSI values fluctuate wildly, and each value cannot be used as is. So this is what I do actually. I do a trim min. So what it does is that it trims the outlier values from a set. Okay, so this is what I do. So I obtain a series of values and then place them into a fixed queue. Then I sort whatever that's inside the queue, and I drop the top and bottom 20%. This is so that these outlier values do not adversely affect the final value that I get. And what do I get? So after having the distances, we can actually able to derive your current location with respect to these 3 beacons through this trilateration algorithm. So what it says that you have the position of 3 beacons, you have your distances to these 3 beacons, you're actually able to determine your position through this series of simultaneous equations. Just solve them algorithmically. Yeah. Okay, so that's actually all for my lightning talk. So if you wish to find out more, you can just go to the SPGroup's booth. My setup will be placed there after this talk. Okay, yeah, so thanks.